Well, before we go into the details of Teapot, uh, I'd like to discuss a little bit what are we going to expect from these approaches. What should we expect from these approaches? Because automation learning tools are good, but they have advantages and they also have disadvantages. So let's start first with the disadvantages. The first disadvantage is that automation learning tools are slow. They are based on exploring multiple options and running different models with different hyperparameters and scoring those parameters and doing comparisons. And all of this takes a lot of time. So we need to make sure that we have enough time in order to run these kind of algorithms. Next, we need to be aware that it is possible that we don't find a good solution because it also depends on having good data, having the data in the proper format, having the data with a very good cleanup. So it also depends on the data itself. I mean, it depends on how much the data represents our problem. So basically, we have to be aware that at some point, maybe the automated process will give a solution that is not a very good solution. We need to make sure that we provide good parameters and good data to the automation learning algorithms if we want to obtain a good model, right? So it also depends on how much data you have. This is what we already discussed. If you have only a piece of data that represents just some scenarios of your problem, but it doesn't represent with enough generalization your problem, you will not have as a result machine learning algorithm that is uh, performing well regarding generalization. Also, automation learning tools um, have some limitations. They can only do with a specific set of models that have been previously configured for the framework or for the package that you are going to use. So it depends on the package, the models that you have available. Some models have, for example, deep learning methods available as part of the automation, but some others doesn't have those methods. So you need to also be aware of what is your data like and what is like the best um, algorithm that can be applied to your data so that when you use an automation learning tool you can make sure that the algorithms that are a good fit for your data are included as part of the exploration that the automation learning algorithm is doing. And last but not least, for large problems, when you have a lot of data, it is quite important that you can run instances of this automation and this automated exploration in parallel. So this is the reason why some of the frameworks supports platforms like Spark or running Python processes in parallel as deep, as we will see later. And the reason for this is that given that this is a long process and it can be very slow, we will want to run processes in parallel so that we can save some time. Well, now that we um, have discussed the disadvantages, I like to move to the advantages. So, for short data sets, the time spent is worthy, I think, because you have a very good data, the data is small, is representative for your problem, and you run an auto machine learning maybe in in the times of minutes, you can get a very good model with no effort at all. It also facilitates operation where the user could not have experience. This is the main reason why we are doing auto machine learning, right? So uh, those tools are able to process our models, our data, train, evaluate, feature extraction, and do a lot of things without having to be uh, thoroughly configured, and they have very good default settings that works for unexpert people. So this is one of the main advantages. It is actually one of the main objectives that we want to accomplish with auto machine learning. They can also can do searching, testing, optimizations more efficiently than humans, and this is important, right? Because sometimes when you have a model, and sometimes when you have data, maybe you have identified the model that better fits your data, but still you have to try and try and try with different hyperparameters. You need to do the optimizations and the evaluations manually, and you can make mistakes. And this is the next point. You can do make mistakes, and if you make a mistake, you can uh, change completely the path or the solution of your problem. So, given that you are doing manual processes, the results are very subjective. Instead, with automation learning, uh, it is not the case. The results are, I wouldn't say deterministic, because there are some frameworks as Tipo that uses randomness as part of the process, and therefore the results are not always the same. But um, at least you can make sure that for those tools that do not use randomness as part of the process, the results are deterministic. Also, they are done more efficiently, right? Because it takes time to get the output, for example, from a training, and then run scripts in order to evaluate, and then run another scripts to optimize or change the hyperparameters and again run. And in those steps, when you copy data from one tool to another tool, or when you are writing code, or when you are transferring the output of one stage to the other one, you can make mistakes. So right now, with these kind of tools, since they're running automatically, everything is automated, you are completely 100% sure that you are not going to make mistakes, right? And the other thing is that you save time regarding or in comparison with the number of options that you can explore. Uh, you can, in the same time, you can explore much more possibilities for hyperparameters and other stuff. So, well, these are the advantages and disadvantages of automation learning. Let's go into the details of Depot.